Hello to everyone. Welcome to the information session of this edition of the International Masters in Theoretical and Practical Application of the Finite Element Method and CEA simulation. In this case, for the ANSYS software and Civil FEM for ANSYS branch. Michael Disi and myself, Ronald Siat, are going to talk to you through the session, which will take approximately 45 minutes. At the end of the session, we will give you an email address and phone contact to ask any questions you might have, and the Master Secretariat will promptly answer them for you. As well, you can use this application and place your questions using the tools that the GoToWebinar has for you. As well, this webinar will be recorded and it will be available on your registration emails and the master's website. We will outline the objectives and structure of the master's program as concisely as clearly as we can. Let's get started.
I will cover each of the areas shown on your screen. I will outline general context, go over the features of the program, the different degrees, branches, and options available, as well as the course structure, the modules which can be taken, and the methodology applied. I will also give you some background information on the program and the team behind it. Towards the end, I will draw your attention to the master's calendar, registration dates, and secretariat contact details. This slide gives a summary of the objectives of the masters, but we recommend that you go to the master's website, which is shown on your screen, and there you will find comprehensive information on the composition and functioning of the masters. Attendees on the master's program are mainly from two areas. One, professional engineers working in the industry who want to enhance their CAE skills. And two, new engineering graduates and graduates from other science branches. The masters not only provide you with an in-depth understanding of the finite element method and the necessary tools to use it, it also trains you how to apply the knowledge directly in engineering companies, in areas of scientific research, and other advanced studies related to this field. For UNED and INCE Cyber, it marks an important milestone on the journey together and their unwavering commitment to excellence in teaching, research, and innovation in the different engineering fields. The program is not the work of any one person or organization, but the combined efforts of many engineering companies, university engineering faculties, and multiple professionals. It is why the International Masters is widely acclaimed by experts in the industry worldwide. In the early 90s, the need for specialists in the use of FEM and CAE simulation for practical professional applications was clearly identified. It was then that INCE Cyber approached UNED with the idea of formulating a master's degree program. A select team of highly experienced engineers and senior professors came together and designed a pilot study program. It was enthusiastically welcomed by the industry, and within a few short years, it evolved into the International Masters in Theoretical and Practical Application of FEA and CAE simulation. Through the program, UNED and INCE Cyber have engaged with industries, governments, and universities all across the world. The partnership has developed important relationships with a select team of global technology and business partners. About UNED. UNED of Spain is one of the most renowned and experienced distance learning universities. specializing in technical degrees. Through the ubiquitous connectivity of the internet, UNED has become a distance learning powerhouse and uses social media, virtual classrooms, and video on demand as ways of enhancing the learning experience. It has 2 engineering faculties, multiple postgraduate and PhD programs, and a teaching staff of over 7,000. For students, UNED has a uniquely dynamic structure and incorporates the latest innovations and technology into its courses. About NK Cyber. Founded in 1986, NK Cyber is an engineering company and provides finite element analysis consulting to the industry, CAE technology to improve design processes for mechanical, civil and fluid system calculation and training. NK Cyber plays a major role in the FEM Master's program. NK Cyber coordinates the Masters and staffs the Secretariat, has responsibility for global marketing, commercialization and management of the program, as well as the development of educational and training materials and the application and practice subjects for the Masters. Tutoring in the expert module and different specialized modules is done by qualified NK Cyber personnel. The company also develops and provides FEM software. From here, we take a closer look at the Master's program. One of the most significant features of the program is that it is 100% online, with easy access to professors and lecturers. The learning methodology is backed up with materials specially prepared to facilitate the recommended learning process. Another significant feature of the Masters is the appropriate balance between the theoretical contents and their application using the software. Both parts are deemed essential to train professionals in the industry. As I mentioned at the start, ANSYS software and Civil FEM for ANSYS branch is presented in this webinar. The other software branch offered by the Master's program, based in Patran, MSc Nastran, and Civil FEM powered by Mark, is presented in another session. The Secretariat will provide you with full information on that software branch. The current software branch has 2 optional engineering branches. The Mechanical Engineering branch using ANSYS family of products, and the Construction Engineering branch using Civil FEM for ANSYS. At the time of registration, you can choose whichever branch is your preferred engineering field. Other interesting features of the Masters are the learning methodologies applied to distance learning and the flexibility of studies throughout the program. I will expand on these concepts in other slides.
This is the summary of the 5-degree programs that we have. There are 2 types of degrees, the ones including theoretical and practical application of the finite element method, and only practical. Later you will see in the course structure the different modules and will be explained better. The expert in theoretical and practical application is the base. It will include the basic modules. There are 5. Later you will see. Then you will have the specialist, which is the expert degree plus 1 specialized module, and then the masters in one branch or another, which is the expert module plus 3 specialized modules, and the final master's project. These 3 includes fundamentals and the practical application using a software of the finite element method. And the new degrees will include only the practical application of the FEM using a software, any of the software that will be explained later. And you have 2 degrees, expert and specialist.
there are two engineering branches, mechanical and construction. The mechanical branch uses ANSYS family of products, including ANSYS Mechanical as main FEM software, ANSYS CFX, ANSYS ACP, and ANSYS Space Claim. The construction branch uses Civil FEM for ANSYS with ANSYS APDL and ANSYS CFX. As the Masters is delivered online, the virtual classrooms are used to centralize the tools available to you. It is there you access study materials, continuous assessment exercises, and self-assessment exercises. There will be online meetings, and you can find more information about them in the virtual classrooms. You can also post questions in the online forums of each subject, and they are answered by the tutors. Exams are also conducted there. The primary objective of the Masters is to provide professional training in FEM. During the program, you will have the opportunity to solve industry-specific simulations such as structural analysis, steel structure advanced analysis, nonlinear concrete analysis, dynamic analysis, nonlinear, thermal and composite structure, pressure vessels, heat exchangers, pipelines, automotive parts, etc. The examples I have just mentioned focused exclusively on professional applications. This is a very important concept present in the whole Master's program. Not only is it about solving basic teaching cases, but also about developing the cases to real applications to also learn, for example, modeling criteria applicable to real models. Specific real cases solved during the Master's program are presented in the explanation of each module in slides coming up.
Here you have the full course structure, and you can see that we have two types of degrees. Here we have the new practical degrees, which are available from this edition. We'll cover all the modules that are inside of this part, and the traditional theoretical and practical application degrees, which are all the modules, including basic, all basic, and specialized modules. Okay, I will first explain the new practical degrees, and then we will explain the theoretical and practical application degrees, which include fundamentals and practice with the software. For the new practical degrees, all subjects are from application and practice parts, which are specialized modules and the introduction to FEM software. But you have the available as well if you don't have any knowledge about the finite element method. Students for these practical degrees can choose MB1, Basic Module 1, which is the general theory of the finite element method. Depending on the number of credits, you have the expert in practical application degree or specialist in the practical application degree. If it's more than 15 or below 30 credits, you have one or another degree. At least 50% of the credits must be from application and practice subjects. So, as you can see, each student can customize its own practical degree. And now Michael will explain the theoretical and practical degrees.
The expert module consists of 4 foundation subjects: FEM, General Theory, FEM, Introduction to Programming, Numerical Calculation, and Material Constitutive Laws, and 3 Application and Practice subjects. The foundation subjects give you a fundamental understanding of the finite element method, which is essential in order to understand what you are going to do with the application software. These foundation subjects are common to both engineering branches. The application and practice subjects are studied at the same time as the foundation subjects, while learning how to use ANSYS if you choose the mechanical branch, or Civil FEM for ANSYS if you choose the construction branch. These practical lessons will equip you with the skills to perform a complete finite element method analysis, including the stages of pre-processing, solving, and post-processing. For all modules, UNED and NK Cyber will provide the materials for the different subjects, the educational software, and any additional study material needed, such as exercises to complete the program. In the mechanical branch, ANSYS is a general-purpose FEM software, and FEM techniques are valid for many different types of industries: aerospace, automotive, oil and gas, nuclear power plants, to name but a few. Here you can see structures of different industries analyzed using ANSYS: a steam condenser, a bolted flange, an offshore platform, a storage tank, and a high voltage tower. These examples are solved in the expert module of the mechanical branch. In all cases, checking of the structures under operation loads is very important to validate the design. For example, internal pressure in the storage tank. Combinations which are usually calculated due to norms are also obtained. Civil FEM for ANSYS is used in the expert module of the construction branch. The software is focused on civil engineering, and it has different tools that make civil analysis, like the ones shown in the images, easier. The civil structures shown, a concrete rooftop, cable-stayed and composite bridges, a warehouse, and a piled cap, are calculated during the expert module. If you advance to the specialist degree, you have 8 specialized modules to choose from. Whichever engineering branch you choose, mechanical or construction, you can select the appropriate modules and software for your areas of interest. For the mechanical branch, the specialized modules are dynamic analysis, non-linear analysis, heat transfer analysis, fluid mechanics, and composite structures. You will use ANSYS for the structural analysis modules, ANSYS CFX for the CFD, computational fluid dynamics module, and ANSYS ACP for the composite structures module. In the construction branch, the specialized modules are dynamic analysis, non-linear analysis, steel structure advanced analysis, fluid mechanics, concrete structure advanced calculation, and geotechnic analysis. You will use Civil FEM with ANSYS for the structural analysis modules and ANSYS CFX for the fluid mechanics module. All modules have a foundation subject and 2 application and practice subjects to help you gain experience with the specific software of your branch. In the next slides, the modules are briefly presented. More complete information about the subjects and modules is set out in the attendees guide on the Master's website. The dynamic analysis module, available to both engineering branches, includes the study of dynamic phenomena that are present in structures or equipment. The initial objective of the fundamental subject is the analyzing of the dynamic problems that arise when calculating a structure. It also provides criteria to resolve them by focusing on specific structural types and providing the essential concepts while identifying the fundamental parameters which characterize the dynamic behavior of structural systems. The application and practice subjects introduce you to the concepts of dynamic analysis of structures by using the finite element commercial software ANSYS mechanical for the mechanical branch and Civil FEM for ANSYS APDL for the construction branch. Dynamic analysis such as modal analysis, harmonic analysis, spectrum analysis, random analysis, and transient analysis are studied during the course and are applied to real problems using the FEM software. The study of this module will help you to understand and learn how to create and analyze dynamic cases of finite element models such as seismic studies of components, buildings or dams, and enforced vibrational studies in different industries: automotive, aerospace, energy, marine, civil, etc. Examples of some of the dynamic analysis which are solved in the practical subjects of this module are: in the mechanical branch, a vibration analysis of a steel tower due to the loads transmitted in the oil and gas installation, seismic analysis of a pipeline, an oxygen analyzer or an Airbus A320 aircraft wing PST spectrum analysis during a taxiing operation. In the construction branch, a study of transient loads in a cable-stayed bridge, a seismic analysis of a dam, or the design of an anti-vibrational pad. These examples, which are solved in the dynamic analysis module, keep the idea of the practical subjects of solving real cases at the forefront of the professional lives of attendees. The purpose of the nonlinear analysis module, available to both engineering branches, is to study the nonlinear problems associated with structures. All the main nonlinearities present in reality, like strains and displacements, material and contact, are included. A complete understanding of this behavior is achieved with the study of the concept of nonlinear structures, the kind of problems that require a nonlinear analysis, the causes of nonlinear behavior, and the differences with linear analysis and the characteristics of nonlinear analysis using finite elements. All of the concepts and the study of these behaviors are applied to real problems in the application and practice subjects using the finite element commercial software ANSYS Mechanical for the mechanical branch and Civil FEM for ANSYS APDL for the construction branch. The study of this module helps you to understand and learn how to create and analyze nonlinear finite element models such as in contact mechanisms, nonlinear buckling analysis in structures, construction processes, nonlinear materials, and geometric nonlinearities, etc. Some interesting nonlinear analysis examples which are solved in the practical subjects of this module in the mechanical branch are the study of a clasp mechanism, the collapse of a rocket fuel tank and a water bottle, and the analysis of a rubber seal. In the construction branch, examples like the construction stage of a cable-stayed bridge, the contacts inside a beam joint, or the nonlinear buckling of a steel frame can be highlighted. The aim of the heat transfer module, only available in the mechanical branch, is the study of heat transfer phenomena. The fundamental subject provides the theoretical knowledge about heat transfer necessary for a specific application in the resolution of general and finite element heat transfer problems, as well as in stationary or non-stationary systems. In the application and practice subjects, you come into contact with and manage from the perspective of conducting analysis using finite elements and through the use of the ANSYS mechanical commercial software, the basic concepts of heat transfer such as conduction, convection, and radiation, while at the same time solving stationary or transient heat transfer problems and other peculiarities of thermal processes, which can be treated like nonlinearities. The study of this module helps you to understand and learn how to create and analyze heat loads in finite element models such as thermal studies of heat exchangers, thermal studies in electrical components, thermal behavior of pressure tanks, etc. Some heat transfer analysis examples which are solved in the practical subjects of this module are the thermal analysis of a fined tube, a heat sink design procedure, a radiation analysis of a system or the thermal stresses in a section. The aim of the Steel Structure Advanced Calculation module, only available in the construction branch, is to introduce and consolidate the main concepts surrounding the advanced analysis of steel structures by combining the theoretical part of the course with the verification part using finite element models. The fundamental subject shows the theoretical approaches that support the current calculation tools and verification of structures, facilitating the application of these tools according to the practical part of the module. The application and practice subject studies the concepts of advanced analysis of steel structures through the use of commercial software, Civil F.E.M for ANSYS, APDL, in different types of steel structure analysis. The study of this module helps you to understand and learn how to create and analyze advanced steel structures finite element models by studying different cases such as the application of steel regulations, advanced nonlinear buckling analysis of steel structures, etc. Some steel structure analysis examples which are solved in the practical subjects of this module are a high voltage tower under wind loads, the design of a steel bridge, and compression buckling checking of a bridge section or the checking of a warehouse structure. The fluid mechanics module, available to both engineering branches, studies problems associated with fluid mechanics, including their characteristics and modelization in order to analyze them using CFD simulations. The theoretical subject studies the fundamentals of fluid mechanics with a particular emphasis on deduction and analysis of mass conservation equations, movement quantity and energy. Furthermore, the characteristics of different flow types are described and the conditions in which the different simplified shapes of general equations can be applied are discussed. Lastly, the finite volume method is applied to some of the flow types studied. The application and practice subjects of this module are studied with ANSYS CFX, helping you to understand the main approaches used in CFD simulations. Mesh-based CFD techniques are studied with the ANSYS CFX software, along with previous specific training in CFD geometry pre-processing procedures. The study of this module helps you to understand and learn how to create and analyze computerized fluid dynamic modules, such as aerodynamics studies in automotive, structures or aerospace, internal flows in heat exchangers or valves, hydrodynamic studies in the marine industry or water management, ventilation studies, behavior of wind turbine, multi-fluid flows, etc. Here you can see some examples of CFD fluid mechanics analysis solved in the fluid mechanics module. The ventilation inside a parting area, checking the smoke behavior created by fire, the simulation of a bullet in supersonic regime, the simulation of the interaction between two aligned turbines, checking how the wake of the first turbine affects the second turbine, a vortex shedding simulation to check the frequency and amplitude of the loads created by this phenomenon, and the optimization of a water treatment structure using a deflecting wall to improve the suction of one of the pumps. The aim of the Advanced Calculation of Concrete Structures module, only available in the construction branch, is to introduce and consolidate the main concepts surrounding the advanced calculation of concrete structures. The fundamental subject goes further into the calculation methods of concrete structures and is a theoretical basis for the study of the practical subjects. The application and practice subject studies the concepts of advanced analysis of concrete structures by using the commercial software F.E.M for ANSYS, APDL in different types of analysis. The study of this module helps you to understand and learn how to create and analyze advanced concrete structures such as slab bridges, advanced concrete buildings, nonlinear concrete structures, concrete design and verification according to regulatory standards, etc. Some interesting simulations performed by the attendees in the specialized module are the study of rebar configurations inside beams and the reinforcement design of concrete floors of a building. The geotechnical module, only available in the construction branch, includes the study of the mechanical, hydraulic and engineering properties of soil materials for application to civil engineering. The theoretical subject introduces the geotechnical concepts of soil behavior models and constitutive equations, seepage, methods for estimating unlimited loads, analysis of retaining walls, slope stability, tunnels, etc. The main objective of the application and practice subjects is to come into contact with and handle in a practical way the basic concepts of geotechnical application calculation using the commercial software F.E.M for ANSYS, APDL. The study of this module helps you to understand and learn how to create and analyze geotechnical models such as diaphragm walls, pile cap analysis, retaining walls, tunnel excavation processes, etc. During this module, interesting real cases like an interaction study during a tunnel's excavation, a diaphragm retaining wall, or a settlement crack analysis of a foundation are studied. The theoretical and practical application of the Finite Element Method and CAE Simulation Master's Program concludes with the final project. This project combines all the knowledge that has been acquired throughout the study phase of the expert and specialist modules and aligns all their aptitudes and capabilities under a common goal in a single project. A tutor is assigned to each project, depending on the areas involved, to guide you during the project process. The project can be proposed by you based on your professional experience or chosen from the master's official list. At this point, I will give you useful information on the program calendar and important dates, candidate requirements, the registration process, and scholarships and fees. Enrollment is now open. It is recommended to register early to facilitate the necessary confirmations and the payment of fees, etc. The expert module starts on February and finishes with the final exams in October. The specialized modules and the master's final project start in May, finishing with the exam period in November. Attendees who were not successful or were unable to take the first exam call of the expert module can take advantage of the second call. Earlier, I touched on the flexible modular structure of the master's program and the different master's degrees. From previous editions of the masters, we know that most attendees combine the master's studies with their busy professional lives. In this slide, we recommend some study options. For example, it is recommended to tackle the expert module or the expert module plus one specialized module in the first year. The specialized modules and the master's final project have a lighter workload, so the rest of the modules can be tackled in the second year or can be completed in the third year. This slide shows the fees for each module. But what I want to make clear to you is, you only pay for the modules you take. To undertake the master's program, you must have a bachelor's degree. To register, you need to complete the online application and submit the requisite documentation for verification at the same time. Once your documents have been validated by UNED, the remaining part of your registration will then be completed. Here are the contact details of the Master's Secretariat. Don't hesitate to get in touch with the Secretariat if you have any questions about the program. The Master's website is the place to go to start the registration process.
You will be pleased to hear this slide brings the session to an end. We hope you have obtained a good understanding of these international masters in theoretical and practical application or the finite element method and CA simulation. Once again, don't hesitate to get in touch with us if you wish to have any matters clarified or require more information. Use the Secretariat email address and we will be more than pleased to help you. Of course, any questions you might place in our tool will be answered ASAP. Our international masters could well be the right opportunity and the right time for you to invest in your professional career and your future, and UNED and Cyber are here to help you achieve your goals and fulfill your dreams. We would like to thank you for your time and presence today. Till the next time, take care and goodbye.